Hi, Mr. Parcia.
What's up? We're back again. What chapters? Oh, this is like chapter 3 and 4.
Chapters 3 and 4.
3 and 4. So like we're
Little
gonna cover
combo.
friction. The combo, yeah.
Yep.
Combos. Isn't that like a snack?
Yeah, it is.
I'm starving. I have to go for some extra chemical energy or food. Gravity. What are we doing? Work. Right?
Work. Yep.
And then you're gonna do like, well, wait a minute. Then you're gonna do the free fall stuff, right?
Yeah. So like gravity and other forces
Nice.
acting on. Okay.
All right, here we go. So I talk about like friction first.
Sure.
What the heck?
Okay.
Friction is always an opposing force. Always goes in the opposite direction. Okay? And we're going to stick to what the textbook, let me get my good eraser, talks about to keep it basic. It depends on a couple factors. We're going to cover that here. Here's the ground. Now you got to look. Now can you go with that camera? You zooming in?
Yeah.
We're good?
Yeah.
Here's my ground. Why aren't we so high tech here? Okay. Ground. Here is a box. Now the boxes are all going to be the same size. Okay. So if they're a little bit off, just, you know, it's all right.
All right.
Here's the box. I'm going to pull the box this way. There's my pull. It's going to be pulled that way, or the applied force for some of you. And against that box, we're going to have the force of friction. And I'm going to use my technology, my colored chalk. I'm out of red colored chalk, so now I'm looking for orange. Here's some orange. The force technology that's fun, right?
I'll have to get you more colored chalk.
Well, who knows?
We'll have to order
that.
that.
The force of friction is going to work against it because there's interaction here. The bottom of this box is going to slide against the floor, so they're going to rub together. Now, the force that you're applying, the object is going this way. Anytime there's a surface-to-surface interaction, friction is going to oppose it that way. Okay? We call this first type of friction sliding friction. Okay? So, and again, I use orange. Here's my creativity with technology. It's orange to show like heat. Okay?
Oh, that's very good.
Isn't that good? Yeah.
Very good.
Old school here.
Thermal energy. Here, make that line a little darker.
All right,
it's
hold
hard
on.
to see here.
Oh,
perfect. That's good.
That's going to have an impact on our quantity in a second.
Right.
We'll see.
Okay.
So now there's a box. Now I'm going to sit on the box. So I'm going to go here. Right here, watch this. Here's another box. Well, the same box. That's the same box. Box. Now I'm going to sit on the box, or stand on the box. Here we go. There I am. Look at that drawing.
Very nice.
Beautiful. Here we go.
Those look like my drawings. I'm not.
Yeah. I'm
not
not
an
very
artist,
artistically,
no.
you know, I'm not as good as Mr. Kirkus. Here we go. We're going to pull. Here's the situation, though. We've added what does friction depend on. One of the things that depends on is downward force. We've added my weight. Okay? So think for a second. You're adding my weight. We're pulling it that way. It's moving that way. Force of friction is opposite. What happens to the amount of friction? Since it's pushing down harder, the amount of friction, now watch this, is going to get bigger. Get bigger. So we're going to make this arrow a little thicker. Do you see that there?
Yep, you can see
to
it.
show that due to the downward push from me and stuff, right? Well, now there's going to be more opposing force of friction. So we've got to pull harder to get the box to go.
Right.
Keep it moving. Am I doing okay so far?
This is great.
So this is downward push, like downward pull.
Okay.
Let's take the same ground. Here's the box. Okay? Now, let's make the ground a little different. Let's ignore me for a minute. Let's make the ground a little bumpy. I'm running out of technology. Hold on. Here's blue chalk. Let's make the ground bumpy. Bumps. The blue are bumps.
Okay.
Sorry, I'm doing that.
That's good. You can see it.
Yeah, the blue bumps makes the ground like rough and stuff.
Right.
So like if we're changing the surface, the ground is rougher. Isn't that a good word?
Yeah.
Rougher. Right? Great grammar, right? Rougher ground. We sound real intelligent. And with being pulled like that way. Rougher ground.
Right.
What do you think would happen to the friction compared to here? The friction will be bigger because we're using a rougher surface. So now we're going to show a thick arrow also. Oh my God, look at that. It's
Wrong
like a
way.
blue-orange arrow.
Oh, nice.
Uh-oh, hold on. Let me clean that up. Rougher surface. More friction.
Great.
Now,
So compared to that first one, now we've got two things that have changed the force of friction.
the downward push,
Right?
and the type of surface.
And the
We got
surface.
rougher.
There we go.
And real quick, you guys can do this, same box. What if we had a bumpy? I'm not gonna do blue, say bumpy, I'll do a little blue. Bumpy and me on top of it, how should you draw that arrow? Well, first off, you're gonna have to pull, you have to pull more to the left, but I'm not gonna get into how much you pull. This becomes even bigger, like a lot more friction that way, that would give you the most.
Right.
The more you push down, the rougher the surface.
Yeah.
Okay, does that make sense?
That's
You good?
great.
All right, I'm
Yep.
gonna speed up through rolling and fluid.
Okay.
Here's rolling. Here's the ground. My voice just cracked. Okay. Here's the wheel. All right. Now the wheel is constantly going to turn that way, and the car is going to go this way. Obviously, where's the friction at? Right here. Okay. A little bit of friction right there. Rolling friction doesn't oppose you as much. It's easier to overcome. It's a little bit more because there's less surface contact, and the surface interaction is constantly changing. Real quick, what if I decided to pretend this is a car? I'm not going to draw a whole car.
All right.
Let's say we add people into the car, or let's say we add weight. Let's add weight here. More weight. What would happen to the value of rolling friction? It won't be as thick as these, because sliding is most difficult to overcome, but it'll still be greater than this. Do you see what I mean? It won't be as big as this. It
Right.
won't be as big as this. Probably be as big as this.
But it
But it'll be bigger than
still
this. It's still more.
increases. Still
Yeah.
increases. Yep.
Exactly. Does that make sense?
Yeah.
You good?
That's
okay.
great.
Now, fluid friction. You know, Miss Camilleri, it's funny. We did a prank call last week
Oh dear.
about fluid friction. We called up like Dick's Sporting Goods in Walmart to see
Yeah.
if they had any fluid friction hockey tables.
Oh, very
You
good.
know how fluid friction works, a little air comes out, the puck rises up. So they said, no, we don't. I said, well, do you, and then I asked the question, I said, do you have fluid friction in your store? Meaning, well, do you have air in your store?
Right.
The guy said, we have 2 left. You have 2 fluid frictions? How's that possible? And then we called Jiffy Lube, an oil
Oh, very
change place.
good. Yeah.
We said, do you do fluid friction changes? The guy's like, what? Fluid friction changes. No, we don't do that, sir. I said, well, do you have stuff that reduces friction in your garage? No, we don't, sir.
Oh no.
That's scary. Okay, here we go. Here's the box. Let's go back to using the box. Now, let's add like oil to the ground. A little oil. I'm running out of colors. Oh boy. Here, yellow. Oil to the ground. There's a layer of liquid right there.
Like from a car, maybe like
Yeah.
leaking oil,
But,
something
yeah,
like
or
that.
Whatever. Yeah, exactly. And now, but there's still surface contact, but it is not as much. Notice the orange arrow isn't that thick, so there's not much heat or friction being produced. Does that make sense?
Yes.
Going opposing you. And the object's going this way, I apologize. Now, what happens if we have the box again? And I don't know if you, can you like zoom in like right here?
Yeah.
See that right there? A fluid is a liquid or a gas. There's air in there. It's technically not totally touching that surface. There's a little layer of air right here. There's friction between the box and the air molecules. This generates very little friction. Okay? Does that make sense? Just like when you have the air hockey table and it rises gently off the surface, turn off the air hockey table. Is it fun? No. Sliding friction. Turn on the air hockey table. You see that puck glide nicely back and forth. You know what you should do? Go home and annoy your parents. Go down to wherever you have, if you have an air hockey table, right? Go down and pretend to play. And then turn it on. I want you to yell, fluid friction, woo! And then turn it off. Sliding friction. Turn it on. Fluid friction. Turn it off. Sliding friction. And that's happy when you say fluid friction, because it's fun. And then sliding friction. More difficult to overcome. Fluid friction, yay, fun! Sliding friction, more difficult to
No
overcome.
fun. No fun.
Is that good? We good so far?
That's great.
All right, gravity, real quick. We're almost done. Mass and distance. Law, universal, whatever. Universal gravitation, whatever it is. All objects in the universe are attracted to each other by gravity. They depend on mass and distance. Now, every kid every year says, oh yeah, the greater the mass, the greater the distance, the greater the gravity. I got news for you. No.
Nope.
The greater
They always
the mass,
mess that up, don't
They
they?
always mess that up. The greater the mass, the less distance, the closer they are. the greater the gravity. Okay? So how do we want to say? I mean, technically, when I walk upstairs, we'll assume from the center of the earth. When I walk upstairs this morning, from when I got out of my car, I went up 3 floors. Did I go further away from the center of the earth?
Yep.
Yes, I did. Did I lose a little? Is there a little bit less gravitational force between me and the center of the earth right now?
A little bit.
Absolutely. But like, is my mass still the same? Yeah, we didn't change our masses.
Right.
But now, in about 5 minutes or so, I'm going to go back downstairs. Technically, my gravitational attraction between me and Earth increases because I'm closer to the center of the Earth.
Yep.
Okay? So, the bigger the mass, the greater the gravitational force. But you also want to make sure the distance is smaller. This is huge. Pause it, say it 100 times. Greater the mass, less the distance. Okay? The greater the mass, less the distance. And some kids, some of us are talking about this formula right here. The force of gravity is equal to the gravitational constant. Ignore this for now. Look what happens. If I increase distance between 2 masses and keep these the same, if these 2 masses are the same, and I increase the distance, go further apart, this value decreases. Okay, this might be a little, just some of you guys watch this. But what if I keep the distance the same between 2 objects and I increase the masses? This value goes up. Okay? So when you increase mass, keep the same distance, gravity goes up. When you move them closer together, gravity goes up. If you keep this the same, this number gets smaller, this goes up. But if you push them farther apart, this goes down. So the force of gravity is directly related to mass, direct relationship, but inversely related to distance apart. Okay? And your teachers in class, if you wanted them to go into that, ask them about it. But again, the key thing is mass distance, greater mass, less distance, more gravity. Is that okay?
That sounds great.
Okay.
Very good. I didn't bring my suitcase over. Do you want my suitcase?
No, it's cool.
All
I gotta get going. So I got 2 minutes here on. I'm working at Texas Roadhouse. I'm a server, right? Here's my tray of food I gotta get. So watch my hand. I'm gonna apply a force. I'm gonna put my hand underneath this tray. Lift it. What's the direction of my force? Up. Which way did the object go? Up. See what I mean?
They match.
They match. Up, up.
Up, up.
Work, work. Now, I'm going to walk over and take the food. Look at the direction of my force. Up. Which way is the box going to go? This way, horizontal. That looks like a right angle. 90 degrees. Cosine of 90 degrees. I mean, oh boy. Now, watch this. Here's your food. Take it. I just dropped the food. Was work done when the box dropped? Think about it. Was there a force acting on the box when it dropped? It went downward towards the earth. What force caused it? Gravity. Did gravity do work? Yes. Did I do work? No. So what I better do is pull up the box, pull it up, work, like this. And I guess, Miss Camilleri, I should put my hands in the people's food. I guess I'll make it later. Like this.
All right.
Hey, yeah, you want to tip me? Here's work, right here. I'm going to put a downward force from your food. You ready? Here you go. Bam, take it. Right? That's work.
Sure.
I pushed down on it.
Right.
Went in the same direction. Maximum work. Now give me a 30% tip.
There you go.
There you go. So we're going to make sure force is in the same direction. So if you have a little wagon, here's a little wagon. You want to pull it this way or that way for more work. It's going this way horizontally. You want to pull it right with the horizontal. If it's on an angle, you're technically doing less work on the object.
Less
okay? We have 2 other videos on work if you need any clarification.
Great.
But I got 3 or 4 minutes left. Did we do okay with this stuff?
I think this is great.
Yeah. All right.
Excellent.
Don't hire me at Texas Roadhouse.
All right. Are we pausing or are we just
it's live?
live?
Right.
Oh, dear.
Now I'm going to take the camera again.
I have to climb up here. Which desk is?
Whatever you want. You're going to go on a desk. You're going to stand on a desk. Oh man, talk about must-see TV and like suspense.
I have the ladder up.
You got a ladder?
This is pretty
Is that a stable? Okay, if you fall, man, don't blame me. Okay, hold on. Whoa, here we go.
All right. So we're going to talk about things that are falling.
Falling.
Like,
Got it.
all right.
Oh, should I come over here?
I don't know.
All right, here we go. Here we go.
So Mr. Parseus said you just dropped the tray, and it was the force of gravity that was pulling that down.
Okay. Be careful.
Now we learned in the last chapter the formula for force. F equals ma. So force equals mass times acceleration. But when acceleration is due to gravity, that can be a constant number. So we're going to find out that mass and acceleration are two separate things. Now, what do we want to start with?
Why don't we see if you can make the book and the paper fall at the same rate?
All right.
Are you going to want it to fall on the desk or on the floor?
On the floor.
On the floor. All right, here, let me kick that chair out of the way.
So here.
Hold on.
Okay, there we go.
Here.
Now, Galileo...
You do have accident insurance, right? Hold on.
Yes, I-
This, again, I'm not a professional camera person. All right, here we go.
Okay,
All right.
So Galileo did an experiment where he was dropping objects, and
He had a lot of spare time in his hands. Go ahead.
he was imagining a world though without any friction. So
That wouldn't be
he
good.
thought of no air resistance. Air resistance is a form of friction that goes, if the object's moving, friction is a force that goes in the opposite direction.
So like gravity pull, like in this case, will pull like the book and the paper down, but air resistance is going to like push it up.
Right.
So they're going against each other.
They're running into the air. They're running into
Nice.
the air molecules, so
All right.
that
Good.
interaction is going to cause friction. All right. So
I would love to see Mr. Siggins walk in here. I would laugh hysterically. I'm sure he'll watch tonight. Hi, Mr. Siggins. We're having fun right here. Go ahead.
So the thing is, though, we have air resistance here.
Are you sure? Hold on. Let's breathe. There's air in here. Good.
air.
Go ahead.
As I breathe out. All right. So I'm going to drop both of these, and we're going to see what exactly is causing the change
Okay.
in how they fall. Okay. Ready?
Go.
1, 2, 3.
Oh my gosh, that took forever.
It did.
Jeez.
It
All right.
took
You want me
a
to?
long
Want me to pick it
time.
up?
So, oh, that'd be great.
All right. Here we go.
All right.
Whoa.
Oh no, we have to keep it.
Oh,
flat.
sorry. Hold on. Whoa. Oh, that's a dictionary. Okay. Here we go.
Very good. So now we drop both of those.
Yes.
Just watch what happens when I drop.
Wait a minute. You're putting the paper on top of the book?
I'm putting the paper on.
Nice. All right. Here we go.
No wait, this one is.
Do you want another piece of paper?
Well, I just hope that this one's not cut exactly. I cut one the same exact size. Let's make sure.
Hold on. Let me see if I can. Oh, yo! I just turned. Oh, this is great. Okay, go ahead.
Ready? 1, 2, 3.
Oh, you know what? Should we try a flatter piece of paper?
Well, that
Did it
one
get
is
caught?
a little bit big, so it's getting caught around the edge of it.
Okay.
That's all right.
That's all right. What should have happened if it
So-
was perfectly aligned?
They fall together.
Absolutely.
Okay. So, can you hand me the
Yes.
paper in the book again? I'm sorry.
Book.
Saving me.
I'm doing work. I'm pulling up here the piece of paper,
Okay.
and I'm going to apply a force upward, and I'm going to push it to do more work. Here we go. Here we go. Here we go. Good.
All right, now.
Okay, hold on. Let me go this vertical angle again.
All I did, I took another paper and I crumpled it up.
Crumpled it up. Good. What? You
right.
crumpled? You wasted paper?
No, this is for a good cause.
Oh, good. Okay.
So I crumpled it up.
Okay.
Changing that, it doesn't change the mass at all.
Are you sure you didn't put any rocks in there?
No
Don't
rocks
cheat.
in there, nothing.
No cheating.
Okay, just
Cheater,
crumpled
cheater,
it up.
pumpkin eater.
But
Okay, good, go.
watch. Now I'm going to drop this paper. Has the same mass as that paper.
It better.
And I'm going to drop it same time as the book.
All right, here we
So
go.
what did we change about this?
We changed.
The shape of it.
Wait a minute. So you changed the shape. So wait. So maybe, like as it's like falling and stuff, I guess air has less chance to. Well, hold on. Air has less chance to like attack it and push it up.
Right. So it's
So-
not going to run into as many air molecules as it would.
Hold on. Let
with
me.
this.
Well, I'm in the work. I'm going to drop this camera. Hold on. So we got this piece of paper. Air's going to get all under that. A lot of surface area.
Not
Oh
so
man.
much.
Okay. Cool.
Okay.
All right. So we're going to
So
drop
it's
those two.
right.
Hold on. Ready?
1. Wait. I've got to hold it right. So. Okay.
This ain't
Ready?
easy.
1, 2, 3.
Oh my gosh, they did hit at the same time.
Okay.
That's impressive. And you
So-
sure you didn't cheat?
I didn't cheat. No.
So,
So the mass doesn't play a part in the acceleration. Now what it did play a part with, and some of you learned this, that it deals with the resistance from the friction, the air resistance that's
Okay.
going against the motion.
nice.
When those forces match, the force of gravity, and the air resistance, we
Balance
reach
force.
something called terminal velocity. And then that's what caused the paper to
So it goes
float
at a
on.
constant, like, so when you hit terminal velocity, it's like balanced forces?
Right.
So like if the gravity is one value and the air resistance is the other value and they're equal, that means the sucker's not going to, the thing that's flying down isn't going to speed up anymore. It's just going to stay at that constant speed?
Stay at that constant speed.
Ah, because
So-
unbalanced forces cause acceleration.
Acceleration.
Got it. Okay, cool.
So two things that influence how much air resistance we have. One is surface area.
Good,
so
good,
we saw
good.
that here. Okay, how
Nice.
many air molecules they're running into, and then the speed at which it's traveling as well. If you're
Bingo.
moving faster, you're running into more air molecules.
Here's a safe activity the kids could do
Okay.
in the presence of their parents,
Okay.
not their older brothers and sisters.
All right.
They could ask their parents to drive on a safe road
Yes.
and have them go very slow and have them put their arm out where there's no cars around or anything else or people.
You don't want your
You don't want to hurt your hand or break your arm.
Right.
Have them drive slow.
Yes.
And then have them speed it up. What do you think happens? More opposing hitting
All
of the
that
air molecules, more
air
air resistance.
resistance.
Or put your if you have a sunroof, put your hand on top of the sunroof and wave hello, and then like have like the on 422, you will feel a lot of air resistance.
Yeah.
Yes, yes.
Now, everyone messes this up too because they forget that air resistance has its special rules compared to solid surfaces in contact with each other.
Yes, yes, absolutely.
So kids always mess that up. They put everything together. But air resistance
got
has two things that affect how much it is.
That's awesome.
Okay?
And air resistance is a type of fluid friction.
Right.
Also, because we call a fluid a liquid or a gas.
Or a gas.
Are we good?
We're good?
Perfect timing. All right, hold on. So let's take a look at all this stuff here. If you want to pause this, there's the friction thing we did. There's talking about gravity. Higher mass, less distance. Don't screw that up. Work, go straight with the horizontal. More work, diagonal.
Force times distance.
Force times distance, or some of you FD cosine theta. Now, if you're displacing, and I'll do this little thing. If you're displacing diagonally, going up a hill,
Oh, yeah, we have
and the force is going with it,
with it.
that's a 0 degree. Ask your
Right.
teacher to talk about that, okay? All right, and then we had the, and then the crumpled paper and the regular paper. Oh, what's that? Oh, look at that. That's the cheapest parachute I've ever seen. Dude, that's like cheap. That's awesome.
That is.
Do that again.
Oh.
Woo. Nice.
All right.
Yeah, nice. Or running parachutes work too. Those
Running
things? All right, cool.
parachutes,
All right, very good.
Great.
All right, it is now, hold on. We're only supposed to be till 3:30. We're here still past our time. It's now 3:40. Uh-oh. All right, I got to get home. All right, thank you, Miss
See ya.
Camilleri. Have a wonderful day. Have a wonderful time. Study, have study
Study,
parties,
study.
whatever. There you go. Study, study, study. All right, peace out. Keep it real.